Hello and welcome to my video, lesson 8.1, angles in standard position with radians. So hopefully you've seen my last couple videos about the unit circle and radians in general, because those two videos are going to help you understand the rest of trigonometry in this course. So from that video, we understand that circumference equals 2 pi r, and on the unit circle, r equals 1. That's the whole point of it being a unit circle. It's just one unit, one radius. So 2 pi r. Now, the circumference then is 2 pi, and that's how we define what a radian is. It is based off of that concept. So what is it to make it all the way around a circle in degrees? Well, it's 360. And we know that circumference is 2 pi going all the way around the circle. So those two things are balanced. Usually people will actually talk about this top one as 180 equals pi. You can certainly use that, but for my brain at least, I think the 360 equals 2 pi seems to just make a little bit more sense due to this circumference concept. All right, so we're going to go ahead and do a couple different questions here, one at a time. We've got like part A, part B, like two versions of every question. I recommend that you pause the video if you think you can do the question and then try it out yourself. So here we have a question, convert 150 to radians, 150 degrees to radians. So anytime we're doing any unit conversion, the trick is that we're going to write the 150 times by something. Now, in this case, it's 150 degrees, so we need to divide by degrees in order to cancel that out. So we put 180 degrees at the bottom and pi radians up top. Now, we normally don't write the rad for radians, but I will do so every time I'm converting, and then I will never do so any other time. The reason why is it makes it helpful in my brain anyway, for me to be able to cancel the degrees and being left with rad, right? So we just need to pull out our calculator and go ahead and try this out. I think this example doesn't require me to show it on my calculator, but you could certainly like simplify, which would mean you get rid of a 0 top and bottom, divide by 3, so it's 5 over 6 pi radians. So it can simplify like that, which simplifying the fraction in radians is most helpful, but I'm also going to give you the decimal answer here, which is what my calculator shows me, ... Okay, but this is actually the more helpful answer, and usually, again, I wouldn't write radians. It's just I wrote it there because it makes the unit cancellation part make more sense. Okay, the other one here is pi over 4, which we know is in radians. So what we have to do is get rid of radians down here and have degrees up here. So we're going to put 180 and pi. Radians and radians cancel. And pi cancels. That's kind of the point. So it's 180 divided by 4, which is 45 degrees. All right. And both of those are examples that come from our unit circle, but we should understand the idea of unit conversion. Okay, let's take a look at positive angles and negative angles. So if we are to draw a positive angle on a grid line, how does that look? And how does a negative angle look? Well, positive always starts in reference to the initial arm. And then we can go 2 pi, which ends up getting about to here. And so this angle that I drew here is 2 2 pi over 3. If we're doing a negative angle, then instead of going counterclockwise, we're going to go clockwise, which ends up going to about to here, which is 120, and this is negative 120 degrees. So again, this moves this way around the circle, this moves this way around the circle. Okay, now that's great, that's important to know, but we also need to know about this word coterminal angles. So coterminal angles are angles that end at the same position. So all of these are coterminal. Let's go ahead and prove it. So the 200 position is going in the positive direction. So this is 180 plus another 20. Right? Now we can draw the 160, negative 160 option, which is almost to the 180, but it has that extra 20 here. Actually, maybe I'll list it over here. 200 degrees, negative 160 degrees. Okay, let's try the next one, which is 560. Now, 560 is a little bit more annoying because we get to 360, and we're like, oh, well, we still have another 200, so now we're going to keep going around the circle, another 90, another 180, so 360 plus 180 plus another 20 to get to 560. So it ends up going right about here, which is 20 degrees as the reference angle. So all three of these end up being in the same position. Yes, one spirals around multiple times, one goes counterclockwise, one goes clockwise, but they're all coterminal, meaning not only do they have the same reference angle, but they're in the exact same position. And that's key. Okay, determine the angles between negative 2 pi and positive 4 pi, which are coterminal with this one. Well, first of all, what we need to do is draw this initial position. So, or at least in my brain, that's how I want to do it. So I end up going over here. This is the 5 pi over 6. Over here is just a pi over 6 in terms of the reference angle. Okay, so that's great and interesting. But to find the coterminal angles, what we're going to do is we're going to take that number and we're going to add or subtract 2 pi. Okay, now this is kind of the general solution to this, where we can add or subtract 2 pi, and we're going to put an n here, comma, where n is an integer. So n could be -1, could be +3, it could be any of those values. And so by putting that in, we can, like over and over again, we can go ahead and solve for the other options. So first things first, I'm going to write down this one, and then I'm going to subtract by 2 pi. Now, if I want to subtract common denominators or from a fraction, I need to make sure I have common denominators. So I'm going to actually be subtracting 6 over 6. No, sorry, 12 over 6. Because that would be the same thing as subtracting by 2 pi. So here's our first one, and then minus 12, which ends up getting us -7 pi over 6. If we subtract again, we get -19 pi over 6. But you can see that that ended up going too far. It goes past the boundaries of this question. Now, if we add 12 pi over 6, we get 17 pi over 6, which is fine. But if we add it again, we get 29 pi over 6, which ends up going too far because again, the negative 2 pi and positive 4, it's negative 12 pi over 6 until 24 pi over 6. So that's why these two are getting crossed off, because they're past the boundaries of the question. Okay, so our final answer is these three are coterminal with each other between those two values. So it's the one on the left and the one on the right. The middle one is obviously the original angle. Okay, reference angles are always positive and are the smallest angle formed to the x-axis. So what is the reference angle for the following? So we always look at the reference angle, which is something we know from 20-1. So what we want to do is draw out this position. And then once we've drawn it, it's hopefully somewhat easy to figure out the reference angle. So this is going from here all the way a little bit past to this position. Now this reference angle ends up being pi over 4 because it just goes, it's always formed to the x-axis. This is really key. So it's this little section in here. Always. Okay, so let's try the next one. This is 210, so this is going around. That's 180 plus another 30. So again, this angle here is 30 degrees past the 180. Okay, determine the angles between 0 and 360 that have the same reference angle as 165. So if you look at these options, actually what I'm going to do is just draw one really big one. Okay, the original one is 165, so it ends up going right about here somewhere. And that is 15 degrees away from the x-axis. So if you want to find all of the angles that are that have the same reference angle, so they're not coterminal, but they have the same reference angle, you're going to end up having all four of these options with 15 in here, 15 in here, and 15 in here. So those are somewhat easy to kind of figure out, but we need to figure out the actual standard angle. So this one's 15, that one's easy. But the other ones are a little harder. This is 180 plus 15, so it's 195. This is 360 minus 15, so it's 345. Okay, so again, based off of like basically our 20-1 skills here. Okay, arc length is based off circumference, but because like this is the idea of radians, right? This is basically the definition of radians. But radians are where the radius is 1. 2 pi is a full circle when the radius is 1. So all we have to do is the same exact thing. This is when we have a full circle, right? So a full circumference. But if we have a partial circumference, then it's still based off 2 pi r. But instead of doing 2 pi, because that's a full circle, what we're going to do is we're going to do the angle, but the angle is in radians. Because it's a partial circle, a fraction of the 2 pi. All right, so this concept, and there you go, now you can actually read all the words, will allow us to solve this question. Now, this question, you'll notice, has an angle that's not in radians. So what we have to do is take the 60 degrees and convert it into radians. Now, because it's one of our 30, 45, 60 angles, we should be able to do this without really thinking. It should just be a memorized answer. So hopefully at some point you get there where you can just go straight there. But if not, you can certainly use the unit conversion method that we stated at the beginning of this unit. So by doing this, we could simplify it to 6. The 0 and the degrees can cancel. 6 pi over 18. Now I can divide by 6 top and bottom, so it ends up being pi over 3. Okay, so now we have that answer. So now we're looking for the arc length. Well, arc length is the partial circumference. So how much of the circle have they gone? Well, or have we gone? So it's the pi over 3 times by the radius. Now, normally the radius is 1 because it's the unit circle, but if it's not 1, then we have to use that number. And whatever units that is, so in this case meters, it needs to end with meters as well. So I'm just plugging it in my calculator, and I get 5.2359877 ... rounds much earlier than that, but we're going to go 5.2 meters as our final answer. All right, I hope this video helps you better understand the idea of angles in standard position, as well as how coterminal angles work, positive, negative angles, converting between radians and degrees back and forth, reference angles, and finally, arc length. I hope this video helped, and good luck.